This is chapter 2.4. This chapter discusses Venn diagrams with three sets and verification of equality of sets. In this chapter, you will learn how to use Venn diagrams with three sets, how to verify the equality of sets, and how to solve set intersection and joint problems. So we have in the Venn diagram shown, we have three sets, set A, set B, and set C. You will notice that all three sets overlap and it creates 8 different regions. These regions have been numbered 1 through 8 in Roman numerals. So our first example is to construct a Venn diagram and illustrate the following. So we have the Venn diagram, and region 5 is where all three sets intersect. In our first example, the universal set is 1 through 10. A set is 3, 4, 6, 7, 8, and 9. B set is 1, 3, 4, and 8. And C set is 3, 5, 6, and 10. So you will notice immediately that when we look at region 5, there is only one element that is common to all three sets. It happens to be 3. So in region 5, the set 3 is in fact the only number that's common. Now, if we looked at, say, set the intersection of A and B, that would include 2 and 5. But what about just 2? We already know what 5 is. So if we look at 2, we see what's common in both A and B. And in this particular case, we have 8 that's common, and we have 4 that's common. And we go through and we do the same thing. And you'll notice that the regions that we have, 5, 2, the region for the union of a region 4, for example, is going to be the intersection of A and C. And in that particular case, we have certainly 6. And then for just the part in region 1, for example, we just have 7 and 9 left. And for region in region 7, we have 10 and 5, the set 10 and 5. And then so now we've done all of the overlapping ones. Now in region 6, we have the empty set. Region 3, we have 1. And in region 8, we have 2. So there's the way we have the illustration of example 1. In example 2, this is very similar to what we've seen in the book. We have the following table where we have vegetables, fruit, and meat. And now we're trying to look at, for the top 5 countries, right, per person consumption of vegetables, fruits, and meats. And we're going to construct a Venn diagram. And to do that, our first step is to, of course, draw a box which is going to be our universal set. And then we're going to draw 3 circles. And then we'll call this vegetables, we'll call this fruits, and we'll call this meats. Now we'll look to see the intersections of vegetable, fruit, and meat for all 3. And we see in this particular case, it's Greece is our only country that's going to show up in region 5. If we look at the intersection of vegetables and fruit, for example, we go down and we see that Israel, for example, is vegetables and fruit is the top high, so we put Israel here. And now we'll look at, is there fruit and meat that happen to be the same? And in fact, we do have Argentina. And then what about vegetables and meat? And we don't seem to have, we have the null set for that. So now let's just look at the meats that are left. We have Portugal, and Austria. For fruit, it looks like it's going to be just Denmark and Thailand. And then finally for vegetables, we have South Korea, Turkey, and China. Okay, and so that concludes how we would do this particular example. So to verify set statements are equal for any 2 sets selected, we use deductive reasoning with Venn diagrams. If both statements represent the same region of the Venn diagram, then the statement are true for all sets A and B. So, determine whether the complement of A union B is equal to the intersection of A complement union or intersection with B complement for all sets A and B. So our solution is we'll draw a Venn diagram with 2 sets A and B and label the regions as indicated. We have region 1, region 2, and region 3. Now we say, okay, what is in fact the union of find A union B? So in this case, A union B is really made up of all 1, 2, and 3, right? Everybody can see that that is absolutely true. So in this case, the union is this. So the complement has to be what? Region 4 in our Venn diagram. So we know that the complement is region 4. Now we find out what A complement is. Well, A complement is everything that's not in A. Well, we see what's in A. A is 1 and 2, so A complement has to be 3 and 4. This also means that for B, B has regions 2 and 3, so B complement, not B, is got to be 1 and 4. So the intersection of A complement and B complement just happens to be the common elements in A complement, B complement, which is air region 4. Therefore, it turns out that A union B complement is equal to A complement intersection of B complement. Both statements are represented by the same region 4. Thus, our statement must be true for all sets A and B. So in fact, we have what's called De Morgan's law, and we've just shown at least one of the De Morgan's law. We can prove the other one the same way, and it makes it possible to change statements and formulas into more convenient forms. For example, A intersection B, its complement, is equal to A complement union B complement. And we just proved that A union B complement is A complement union B complement. Now we have the following. Let U equal A, B, C, D, E, F, G. Let A equal A, C, E, F. Let B equal B, C, D, F, G. And C is equal to E, F, G. We want to find the intersection between A and B. Then we want to find A complement C. And then we want to find A union B complement union C. Well, in the first case, we're going to show you that next. We want to note that A union B is equal to CF. Why? Because the common elements between A and B are C and F. A complement C is just equal to G because A complement is BDG and C is EFG, and now we see the common elements. So I want you to pause the video and see if you can do the last one, which is A union B complement union C, and see if you get the same results that I do. Go ahead and pause. Well, as you see, the answer is going to be A, B, D, E, F, and G, but we start out first by knowing that the intersection of A and B is CF, and then the complement of that is just A, B, D, E, G. And then we know that C is E, F, G. So we just have all the elements that are in the complement of A intersection B with or the elements that are in C. And that is our result here. So in summary, we learned about Venn diagrams, we learned about the equality of sets, we learned about how to solve set problems. This concludes chapter 2.4, and the next step is to actually use Venn diagrams to solve set problems.